Hello everyone, welcome to the P1 uh, P1 Classical Mechanics program. It's a P1 Classical Mechanics program. Basically, this lecture is called P101.0. 0 stands for the introductory part. I'm doing the intro, right? This is the intro to P101. This is the first part of the lecture. This lecture has no mathematical parts. There is no complicated stuff in this lecture. It will be easy for you to understand. This is just to smoothen things before we begin into the more complicated parts. So as I have promised you that this lecture series will have a very elaborate expansion of what basic physics is. So I will explain almost everything that is associated with the classical mechanics. We will start from the basics. We will get into the complicated part, okay, in time. So um, what I'm going to start off is now that I'm going to tell you some information regarding this series. So if you are an expert in physics, then you don't need to look through all these lectures. You have to, if you're a good person who has a reasonable understanding in physics, you don't have to come back until 110. So you can skip these 10 lectures. And if you're an expert and, and a very good expert, then you can maybe you can wait until P120 as well. It's up to you. So I'm not going to say do any complicated stuff until P110. So we will do the basic stuffs, okay, almost all classical mechanic basics. And we'll do a lot of problems. We'll do a lot of things in within. This will be a very comprehensive course. It is supposed to deliver some foundation level physics to you. Okay, that's my intention with this program. So I want you to get um, get in ease with this program. So that's why I'm introducing some stuff along with the video. Now let's get into some physics now. Now, what is the need for physics? Okay, that's an important question. What is the need for physics, and what is the need for classical mechanics? So if you I can explain it in a certain way. Okay, let me take an example. If you are standing in a place, some place, anywhere around the road, anywhere, let this be you or me, whatever, let this be the person. Now this person is standing at the point X. Let there be a ball, a rubber ball or a football, whatever. So this is at a distance d from the person. And what you can do now is the first initiative in physics is that you can record all this information regarding the ball and the person and all the things that are surrounding them. So you can record like digitally or in a paper or mathematically, which is what we are going to do with this program. In physics, we look at things mathematically. So you can record all this information. You have recorded. Okay. Now someone came in and kicked this ball in this direction. So the ball is shifted to this place. Okay. Now the distance traveled by the ball is x, and this distance, let it be d dash. Okay. So what happened to the information that we have collected? What happened to it? Well, the information has become something else. Well, not completely different, but it has become something else with an additional factor of position of this inside. Okay, this factor came inside. That's what happened. Okay, then now we have got the two equations. Well, some two equations or two forms, right? Two forms of this whole system. Now this system is going to change. This system is changing into this. That's what we observed. Now let's take a same case in a different perspective. different viewpoint. You assume that this is the surface of earth and you are the guy, that same guy standing on that ball, on that place, with a ball here and shifted to here, right? The same case. And you are rotating around the sun, right? In an elliptical orbit, you are rotating around the sun. Let this be the case. Well, what happens now? It's the same case as here, but now here you are rotating around the sun. We are considering the fact that sun is there. Sun is there. Okay. So if you are doing this, then what happens? You can now introduce the system of Earth, system of orbit, system of sun, the force with which you are attracted to the sun, and all this information. Now you have a broader set of information, a bigger set, very big set of information. Before kicking the ball, this will be the information. After kicking the ball, the broad set, the big broad set will look something like this. All the same, except for the fact that the ball has shifted. Okay, everything else is the same. If it happens in an instant, okay, it means the kick happens just within a fraction of a second. So that displacement is recorded here, right? So this is very useful if you can predict the future like this. It will be useful, right? If you can predict the future like this kind of a setup, if you have this kind of a setup, then it will be very great, right? Now how can you do that? Well, that's where physics comes in. Physics use this kind of a method. Classical mechanics purposefully deal with this kind of a situation. You are going to handle this kind of a case where you devise a set of equations, some equations that can explain the situation that is happening, and you have another equation for a different state, right? For a different state you have another equation, and for the same state you have a different equation. So this difference can be compared and it can be used to predict the future. That's the most important part. You can predict the future by looking at the equation. That's the use of physics. Now with that aside, okay, if you keep all that thing aside, now I'm going to introduce you some different thing, one different small thing along with this video, which is called, if you, let's take the same case. Okay, you are here, X is the place, there is a D and the ball, and there is the ball here, and there's D dash. Now if you look from this frame, okay, the frame, okay, I'm just calling this a frame, you will understand it why. So in this frame, if you look at the ball in this frame before was D distance away from the frame. Now afterwards it's D dash distance away from the frame. Okay, now what about this frame? Okay, this frame, what about that frame? Well, now the ball was initially at 0 distance because it was in the frame. Now afterwards this will be X distance from the frame. So depending on the frame from which you are looking at things and physics will change. The physical laws can change, right? The laws can change, the equations can change. Okay, so will the laws change? It's a question which we will not answer right now. It will change anyway, but we are not going to answer it right now. But let's look at the case as in we were going around the sun. Now look at the sun. If the ball is here someplace and afterwards it will be here, so there is an acceleration in this direction. So this acceleration means when you're looking at it from this frame, your ball is accelerating for an instant, right? After sometimes it comes to a different state, so the velocity is increasing for a particular second. If you look at look from this frame, things is different. That ball has moved from this point to this point, right? Now, as the frames are there, like there is a frame with which you can look at things. Now, my question to you is there a frame in the world where you can sit and relax and everything around you will be the same, or it won't change? Even anything moving will be the same. Is there such a frame? Is there such a frame where everything will be the same? Well, there isn't. That means every motion or movement that is happening around the universe, like as in the case of our solar system, you will be moving with some velocity even if the ball is still. Okay, if the ball is still, you will be moving around the sun in some velocity, and the sun is moving around some black hole with some velocity in our galaxy, right? The whole part of the galaxy is moving around within itself, and the galaxies will move around a bigger black hole. So effectively, a thing that is still is actually not still. So everything is moving around. There is no point with which you can say that everything is still, and that you can call that that's the place of absolute reference point. In other words, Newton called it inertial frame of references. There is no inertial frame of reference. Okay, so every frame of reference is relative, and it will be moving or in motion with respect to some other frame of reference. It will always be like that. Okay, so with that piece of information of frame of reference discussed here, I'm going to end this introductory part. I'm going to remind you that we haven't discussed any mathematics or complicated stuff in this part. We won't be discussing it right now, but we will get there. We will get into deeper points, deeper bits of information for the next lecture, which is P101, next part of the lecture, 101.1. So it will be introducing the concept of units. Okay, units will be introduced. That's the first thing I'm going to introduce, first serious thing. Okay, so thank you.